Corporate finance practice problem using Excel deferred annuity. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, we're down here on the practice tab as opposed to the example tab, noting that the example tab is in essence an answer key. We have our information on the left-hand side. We're going to populate that information into the blue areas on the right-hand side as we work through the problem, working the problem in a few different ways. The outline of the problem is we have the annuity starts. It's a deferred annuity. So in other words, we have an annuity that is deferred in terms of its starting date. It's going to start at some point in the future, not as of today, not at time 0. So it's going to start 2 years from today. So we're going to start the annuity 2 years from today, and the payments for the annuity, like normal, are at the end of the period typically. So then we have the payment amount, which is going to be the $25,000, and then the years are 10 years, and the rate is going to be the 14%. Now, the tricky thing here is that if we use our annuity calculation, which we can use, we'll practice using the annuity calculation, then we typically bring back the annuity calculation to the starting point of the annuity, which is 2 years after, the current date today. So there's a couple ways that we can do this kind of problem. If it is an annuity, then we can do the annuity calculation to the point in time that the annuity starts. And then once we have that lump sum present value, we could take that lump sum and use our present value of 1 calculation to bring it back to the current day. Or we could simply convert the annuity calculation into present value of 1 calculations and just do a present value of 1, taking each of the calculations back to the current period, which, if having Excel, is not too difficult to do either. So we'll do the first method first. We're going to break it down and do 2 calculations. One is going to be the annuity, bringing it back to the current time period of the annuity, the first date of the annuity, present valuing back to that point, getting a lump sum. Then we're going to take that lump sum, present value it back to today. We'll do this first with a formula. So we have the formula down below. We're going to put that into our table in a similar way as we have seen in the past. Outer column P times this whole thing in the middle, and then we'll bring in the intercalculations, including the numerator, into the inner columns. So I'm going to start up top with the payment, which is going to be the $25,000 on the annuity. We're then going to have 1 here, and then I'm going to pull in this 1 plus R to the N in the inner column. 1 R then is going to be the 14%, the rate. Percentifying that cell by going to the Home tab, Numbers, Percentify, underlining it, going to the Home tab, Font, and Underline. Then we're going to use the trusty sum function to sum up, S-U-M, the 1 and the 14, giving us 114, percentifying that cell. Home tab, Numbers, Percentify. Then we're going to take that to the power of n, negative n, that being the number of periods, negative 10 in our case. Underlining that cell, Home tab, Font, and Underline. We're going to bring this on out to the outer column, that of 114%, Shift 6, caret, in other words, 10 periods, Enter. And we're going to add some decimals, Home tab, Numbers, decimalize, Underline, Home tab, Font, and Underline. And then we can do our subtraction, getting us finally to that numerator number. That's going to be the 1 minus that decimal. And then we will add some decimals, Home tab, Number, decimalize, like so. And now we have the numerator. Now we need the denominator, which is simply R. So we're going to say this equals the 14%. For R, percentifies this, Home tab, Number, percentifies, Underline, Home tab, Font, and Underline. Now we'll bring this out to the outer column. We have the numerator and the denominator in one number, so we could go ahead and divide them now. Numerator divided by the denominator. And now we'll add some decimals here. Home tab, Numbers group, decimalize, Underline, Home tab, Font, and Underline. Now we'll multiply out finally, which will be the 25,000 times this number we just came to, giving us then the 130,403, adding a couple decimals, Home tab, Number, just a couple decimals. Okay, so now we brought it back with the annuity. This would be the present value, but it's present value basically 2 years from today, because the annuity started 2 years from today. We still need to bring that lump sum back to today, which we could use a present value of 1 calculation. We will do that in the second half of the problem, but before we do so, we want to recalculate this one a couple times and show another method that we could do this. So let's do this in terms of breaking down this annuity to present value of 1 calculations, thinking about how to do this in terms of an annuity. Also thinking about how you could use this method to basically just do it instead of having an annuity, just use present value of 1 calculations. So first, let's get to this number again. I'm gonna go back up top, and we're just gonna say period 1, period 2, and then we're gonna select those 2 periods and autofill them on down, and then center, home tab, alignment, and center. We'll pick up the payment, which is going to be $25,000 on the payment. We're going to go ahead and present value 1 at a time here, not an annuity, present value of 1, negative, and PV, shift 9, picking up the rate at the 14%, comma, number of periods, 1, not 10 here because we're just doing this 1 at a time, comma, comma, future value 25. So that's going to be our first value after the first time period. Then we'll continue this on down. 25 payment for the second one. Present value in this one, 2 years out. Present value of 1, 2 years out. Negative. PV, shift 9, rate 14%, comma, number of periods 2, comma, comma, payment or future value 25, and enter. Now we have the prior present value after the first year plus the present value after the second year, and so on and so forth. We can then copy this down, but we want to see if we need to absolutize anything. And when we look at the present value formula, this one looks like 1. I do not want that to move down. Therefore, we need to absolutize it, making it an absolute reference, in other words, in F6. So F6 is right there. I'm going to put my cursor in F6, select F4 on the keyboard, $ before the F, $ before the 6, making it an absolute reference. You only need a mixed reference, but absolute is easier, I believe, so that's what I will use. Selecting those 3 cells, fill handle, and autofill on down. We then get, once again, to our 134.02.89. So it's rounded here. Now note, what we have here is a present value, and we're just mirroring here, bringing it back to the current point of the annuity. However, you could use the same method and just say, hey, I'm just going to make a present value of 1 calculation for 10 time periods and not deal with the annuity, considering the annuity starting in the future. Why don't I just bring every payment back to the current day, meaning we're not going to start it here at 1, but we will start it at 3. And that's because the annuity is starting 2 years from today, and then the annuity means that the first payment happens at the end of the annuity. So we'd start this at period 3, and I'm just going to say this will be the last one plus 1. So 4, and then I'll copy that on down, copying this on down. So we could do this method, and basically this would be present valuing the entire thing. And we could do this instead of doing an annuity. We could just make it into present value, 10 present value payments. The first one starting not 1 year from now, but 3 years from now, because that's when the actual payment will be taking place, and then count up 10 periods from that. So just keep that in mind. We'll do that again later, but we're going to go back to our original method, 1 to 10. So we're just basically mirroring another calculation to get to this number, which we would then have to bring back to the current period by using a present value of 1 calculation. Let's do it again using an annuity formula. This is going to be equal to, let's make it a negative, present value, shift 9, rate being 14%. Then we have a comma, and then number of periods, which is going to be 10, comma, and now we have the payment as opposed to 2 commas in the future value, this being an annuity, 25,000, and enter. So there we have it again, the 134.02.89. Let's do it one more time with the tables before we get to the second half of the problem, because the table time is fun. So 25,000, we're looking at the table now. We're looking at you table. It's going to be 14%, 10 periods. 14%, 10 periods. So there's the 14% and 10 periods, which is 5.2161. 5.2161, 5.2161, 5.2161, 5.2161, 5.2161. Adding decimals, home tab numbers, 4 decimals. And then home tab font, underline, multiply 25,000 times that number we just came up with, 134.03, about the same as here. Let's add a couple decimals. And slightly different due to rounding. Okay, let's finally do the second half of the problem, if you wouldn't mind moving on, finally, second half. So now we have that amount, which we came to before. I'm going to pick it up over here from the annuity 13402.89. I'm bringing it from the formula because it's a little bit more exact than the tables, adding a couple decimals. That then needs to be brought back to the current day because the annuity doesn't start for 2 years from today. So now we have that lump sum that we brought back to a period 2 years from today. So it's kind of like the future value 2 years from today. And we need to bring that lump sum back to today. So we could do that with a present value of 1 calculation. This formula, present value equals future value times or over 1 plus r to the n. So we will do that then, or do that now. And so do that then, do that. Okay, we're going to say this is going to be 1, and then this is going to be the 14%, 14%. Percentify that, home tab, numbers, percentify, underline, home tab, font, and underline. Summing up using the trusty sum function equals sum, shift 9, 14, and 1. Percentifying that to give us the 114, home tab, numbers, percentify. Then we're going to go to the number of periods, that being this time 2 periods. We're bringing it back 2 periods back. And we're going to then go home tab, number, or font, underline. And then this is going to be equal to the 114 caret shift 6, 2. And then home tab, numbers, decimalize. And then home tab, font, underline. And then we can finally say this is going to be the numerator divided by or over the denominator. Add a couple decimals, home tab, number, couple decimals. And then if we were to see what amount would be on the table, I'm going to take this divided by that amount. That's the amount that we would expect to then see on the table. Let's do this again. Let's do this with and that would then be the present value. So that 2 kind of step process we had to do, meaning do the annuity first and then present value of the annuity, considering it didn't start for 2 years, would give us the today as of time 0 present value. We also calculated again using that running balance method in a second, but let's recalculate this number a couple different ways. The more likely way we would do this, the easy way, the magic way, would be to use the Excel function, which would be negative present value shift 9 rate 14%, comma, number of periods, now 2 numbers of periods, comma, and then the payment is not comma, comma, because this is a present value of 1, and that would be the 13402.89. That gives us, once again, the 103.40.79. Let's do it with the tables this time. Table time. Table time. So then we're just going to say on the tables, we're looking for 14 and 2. 14 and 2, picking up the proper table, present value of 1 this time. 14 and 2, 0.7695, 0.7695, 0.7695. Multiplying 130 times that 0.7695, we get the 103.4502, close to what we got before, slightly different due to rounding. Tables taking it out to 4 digits, as opposed to if we took it out a few more digits, it would look like this number over here. Now let's do that running balance again, just so we can say, okay, what if I just want to make this like a running balance present value, like 10 present value of 1 calculations? Then I don't need to do a 2-step method. I'll do a similar kind of running balance we did before, but just bring every payment back to the present. So in other words, the first payment, if I look at our data over here, the annuity starts 2 years from now, and you usually get paid. An annuity means you get paid at the end of that period. So I'm going to say the first payment actually happens 3 years from now, and then I can just count up 10 years from there. So I'm going to say the first payment happens 3 years from now. I'm going to put period 3 and start there, because then I want to basically count up from that point, 3, 4, and so on, and it's going to go 10 years from there, so that would be up to 12. So we'd have 12 periods that would be covered. And then let's go ahead and center this, home tab, alignment center. The payment that the first payment's going to happen 3 years from today is going to be that $25,000. And now I could just do a present value of 1 and just do 10 of them, and not have to deal with the annuity business at all. We'll just do a bunch of present values of 1, which would be tedious mathematically, but not so tedious if you have Excel. So I'll just say negative present value shift 9, rate being the 12%, again 12% on the, or 14%, sorry, on the rate. comma, and then the number of periods I'm going to say is 10. It's not 12. I mean, it's, sorry, 10 periods total, but we're going to pick up period 3 because this is present value of 1, not the annuity, and then comma, comma, the future value 25, and then enter. So that we brought this one all the way back. It's a present value of 1 3 years from today, because that's when the first payment of the annuity will start, given the fact that the annuity doesn't start for 2 years, and then you get paid at the end of the year for the annuity. So that's going to be equal to the 16,874 about. Then we can continue on from here. 25,000 for the second payment, present valuing it, negative present value, shift 9, rate all the way over here, 14%, comma, and then we've got the number of periods. Let's see if I can get this right this time. Number of periods is going to be 4, second payment 4 periods out, and then comma, comma, future value is going to be that 25,000, and so on and so forth. So then we can add these up, 16,874 prior payment plus the present value of the current payment that we're talking about in period 4. We can copy this down, but I need to make sure that I have an absolute reference for the interest rate. So if I double click on here, that interest rate is on X10. So X10, that one. Putting my cursor in it, selecting F4 on the keyboard, $ before the X and 10, making it an absolute reference, absolutizing it. Then selecting those 3 cells and putting our cursor on the fill handle, auto-filling on down. We then get to the 341. Let's go ahead and add some decimals here. Home tab, numbers, couple decimals. So the 100, 340, 79. That's too many decimals. I don't want that many decimals. Okay, so 100, 340, 79, 100, 340, 79. So you could just simply do it using this method. And you might say, well, why wouldn't I just do it that method? If you have Excel, you could, but you can imagine this scenario being quite long as well. The annuity might be, a 30-year annuity or something like that, which you could still do fairly easily using this method, but it's a little bit more difficult to present that way. And if you just do the 2 calculations, you could use basically simply this calculation and this calculation, right? The present value of the annuity and then the present value here, and 2 calculations to kind of figure that and show it quite quickly as well. And if you do this in a book problem, of course, they're probably going to want you to do the 2 methods, present value of the annuity and then present value of the lump sum.